Good morning to everybody. Hope everybody is fine now. Today we'll discuss about a set, actually introduction of set. So first of all, the definition: a set is any collection of well-defined collection of objects or anything. So a set is any collection of objects specified in such a way that we can determine whether or not an object is or is not the collection. And the objects or any places or any things must be defined and well defined. So useful identities and equations we have to use in sets. First identities will be a union empty set equals to a intersection union equals to a, and this is called actually identity loss. And domination loss, any set A union U, U means actually universal set equals to U, and the intersection of this set with empty set will be only empty. Now idempotent loss, that means same set A union A will be same set A, and A intersection A will be also A, and this is idempotent loss. And complementation loss, that means complement of complement will be only the set itself. And commutative loss, A union B equals to B union A, and A intersection B equals to B intersection A. This is called commutative loss. And associative loss, A union B union C equals to A union B union C. In this way, now distributive law, A union bracket B intersection C equals to will be bracket A union B intersection bracket A union C. And this is the distributive law. Now, very important laws, which is very useful in electrical circuit and in application of business and economics, the De Morgan's law. So complement of A union B equals to individual complement of their intersection. That means A union B complement equals to A complement intersection B complement. Similarly, complement of A intersection B equals to individual complement of their union. So this is called De Morgan's law. Now, absorption loss. That means A union bracket A intersection B equals to A, and A intersection bracket A union B equals to A. So now the complement loss, A union A complement equals to universal set, and A intersection complement of A will be empty set. So this identity is called complement loss. So we have discussed actually the set identities and laws of and equations. So first of all, what is set? Actually, I have defined in a set is a well-defined collection of anything, distinct objects. The objects in a set are called the elements or member of the set, and the set is denoted by capital letters. A, B, C usually denotes. So lowercase letters, small a, small b, c denotes the elements of a set. Usually we can use this. So for example, the collection of the vowels in the word probability and the collection of real numbers that satisfy the equation x square minus 9 equals to 0. This is the example of set. The collection of two-digit positive integers divisible by 5. This is also example of set. The collection of great football players in the National Football League. It is also number of great player. It is also a collection. So this is also set. The collection of intelligent members of the United States Congress. It's also the example of sets. Now the set with no elements, also called the null set, denoted by the symbol this, actually empty set. This is called also empty set. For example, the set of real numbers x satisfy the equation x square plus 1 equals to 0. Actually, it has no solution. That means real solution, because x equals to root over minus 1, which is actually imaginary number. This is why it has no real roots. This is why the set of solution of set will be empty set. So these are the example of empty set. Now, what are the finite set and infinite set? A finite set is one which can be counted. That means only countable members or elements of a set is called finite set. For example, the set of two-digit positive integers has 90 elements. Two-digit positive integers has 90 elements. An infinite set is one which cannot be counted. That means uncountable set is called uncountable elements of a set is called infinite set. For example, the set of integer multiples of the number 5. That means 5 multiply 10 multiply 15 multiply 20 dot dot can never be finished. So this is the example of infinite sets. Now notation of number of element of A. This is called actually number of element of A. For finite sets, A, number of element of A is the number of element of A. For infinite sets, A, right, number of elements of A will be what? Infinity, because there are number of elements will be infinite. Now the cardinality, now the, this is, I have discussed the cardinality of a set. Now, specifying a set, list the elements especially, for example, capital C equals to A, O, I, small letter, and list the element of implicity, for example, K equals to 10, 15, 20, 25, that means multiple of 5. So use set builder notation, for example, Q equals to X such that X equals to P by Q, that means rational, where P and Q are integers, but Q does not 0. So this is the example of specifying set. Now the set U that includes all the elements under the consideration in a particular discussion and depends on the context. This is called a universal set. For example, the set of Latin letters, the set of natural numbers, the set of points on a line, etc. are actually universal set. Now the membership relation, let A be a set and X the sum objects. Suppose notation, we can say it X belongs to A, or X is the element of A. And this meaning actually X is a member of A, or X is an element of A, or X belongs to A. Okay, and negate it by writing. For example, X doesn't belongs to A. That means X is not element of A, or X is not a member of A. For example, we can write B equals to A, E, I, O, U. That means all vowel, there are 5 elements, and E is belongs to vowel, but small b doesn't belongs to B, that because B is the consonant. Now, equality of sets, when two sets will be equal. So two sets of A and B are equal, denoted by A equals to B, if they have the same number of elements. Okay. Otherwise, A doesn't equals to B. For example, the set A of odd positive integers is not equal to the set of B of prime numbers, because the set A is odd positive integers is not equal to the set of B, which is the prime numbers. Prime number, you must know, the number which can be divisible by 1 and by itself is called prime number. So not all odd numbers are prime number. This is why it is not equal. Example 2, the set of odd integers between 4 and 8 is equal to the set of prime numbers between 4 and 8, because the set of odd number between 4 and 8, odd number which one? 5, 7, only 2. But between 4 and 8, 5, 7 also prime number. This is why these two sets are equal. And subset, which is called actually subset. A is a subset of B if every element of A is an element of B. That means all elements of A exist in B. Notation, A is the subset of B. For each set A, we can write the set will be the subset of itself. That means A is the subset of A. For each set B, we can denote empty set is also the subset of any sets. So we can write empty set is the subset of B. A is a proper subset of B if A is the subset of B and A is not equal to B. That means the element of A and element of B are not equal. Then we can say A is the proper subset of B. Now, what is the union? The union of two sets A and B is A union B equals to X such that the element X belongs to A or the element will be belongs to B. The word or is inclusive. So union can be denoted by or plus. Similarly, the intersection of a set A and B can be written as A intersection B equals to X such that X are the element of A and X also the element of B. And means what? The common element. X will be the common element. So that, for example, the let A be the set of even positive integers and B is the set of prime positive integers. Then A intersection B will be 2 because 2 is the positive integers and also positive prime. This is why 2 is the common. Definition: A and B are disjoint if A and B have no common element, then the set is called disjoint. Now, if A is a subset of the universal set U, then the complement of A is the set, complement of a set can be written as X belongs to U such that X does not belongs to A. That means A will be deleted from the universal set. So we have noted this, these are the idempotent law you must know from our first slide. So union in Venn diagram, universal set can be denoted by this, and here A is represented as a disk inside the rectangular region represented by U. So the whole the region of rectangular are the universal set, but small a ball will be the any set inside the U. So possible Venn diagram for two sets. This is actually union, and this is also union, universal set. And here B is the subset of A, and A also subset of universal set. Now the complement of a set can be written as, that means from the universal set we are deleting the element of A, then the shaded region will be the complement of a set A. Now the union of two sets, suppose A is the first set and B is the region of second set, then A union B can be found by this. So R1 will be A intersection complement of B, and R2 will be A intersection B, and R3 will be A will be deleted. That means complement of A intersection B, and R4 also intersection of their complement. So we have defined actually what is set and with examples. Okay, now the Venn diagram, logic and Venn diagram of set we have defined here. Now let us see the Venn diagram. Using the numbers 0, 1, 2, dot, dot, 9, illustrate the set A equals to 4, 7, 9 and B equals to 1, 2, 3, 4, 5. If we take these two sets, then the solution use a Venn diagram like this. A is the first ball here and B is the second ball. Then 4 is the common element. So A intersection B will be 4 because 4 is the both sides. And 7 and 9 are only in a set A. So 7 and 9 only in set A. 1, 2, 3, 5 are only set in B. Okay. And 4 are the common elements. 0, 6, and 8 are not in A or B. So that means if we take the difference, if we see observe in Venn diagram, 0, 6, and 8 are not in A and B. So it will be the outside of the ball A and B. So now let us see the key definition we using Venn diagram. So intersection, members of both set A and B. This is the intersection area for set A and B. And this is the pink shaded. So this is the intersection B. Members of set A or set B or both. That means we are defining union. That means there are three region. This first region without B part, and these are the common region. And this part, third part, is the without A region of B part. So sum of all three parts can be denoted by A union B. So complementary member not in the set we have defined earlier. Now by using Venn diagram we can define the universal set, whole rectangular of pink color and uh, green color. So the complement of a set will be the pink color. So the pink colored pink will be the complement of A. That means I will be deleted from the universal set. So universal set will be what? All members. All the members of the whole rectangular region. That means all pink area will be the universal set. All members of set A are in set B. Okay, because a shaded region will be inside the B. This is why A is the subset of B, and this is the this is called actually subset of A is the subset of B. Number of elements in a set A, number of element in a set A, and number of element of empty set will be 0. We have to remember this. From the definition of empty set, we get the number of element will be 0. So now another Venn diagram illustrating set. So A union B complement, what we can say, A union B complement. First ball A and second shaded ball will be B. Then this is the figure of A union B complement. That means B portion will be deleted from the universal set. So all pink colored equals to A union B complement. Now similarly, A complement intersection B complement, what will be for the both set A and B, the pink colored area is called A complement intersection B complement, because A and B two sets are deleted from the whole area of universal set. So now A intersection B complement, what will be? A intersection B complement means B portion will be deleted from the universal set. So B portion will be deleted from A portion. Now A union B whole complement, what will be? So that means A union B will be deleted from the universal set. That means pink color is A union B complement. So A complement union B complement will be what? Pink color. Then A complement will be denoted, or B complement will be denoted, and A complement intersection B complement also deleted. That means the pink color is Now, what is the shaded region? We can say what's the shaded region. Shaded region that means pink color area. That means B portion will be deleted from A. Okay, and universal set also. So this is actually called B intersection A complement. So A will be deleted from B portion as well as. Now what is the shaded region of this pink color without pink? This is called actually A complement union B. If you think you get this one. Now what is the shaded region? A and B, A union B complement. That means A union B whole complement will be the shaded region. Now, what is the shaded region will be this of pink color. Actually, this is the A intersection B and B intersection C and also A intersection C. So we can write is B intersection bracket A union C. This is actually distributive law. According to the distributive law, we can define this. Now, what is the shaded region of this? Shaded region will be actually A union B union C complement. That means you have to we have to delete the elements of A union B union C from the universal set U. Now what will be the shaded region? And this shaded region will be actually A union C union B complement. So similarly, we can solve some practical examples here. Actually, there are universal set from 1 to 15. So n is the natural number less than 16. Okay. So we can describe the set A and set B taking all elements. Actually, set A is the even numbers and set B is the prime numbers. Prime number what? The number which is divisible by 1 and by itself is called prime number. So we can describe here the set U, A, B, C. Okay. Actually 1 to 30. 1 to 30 serial number. That means smallest element will be 10 and largest element will be 30. So universal set U equals to 10 to 30, 10, 11, 12 to 30. So here A is the even numbers, all even numbers between 10 and 30, and B is the multiple of 3 between 10 and 30. So and C is the multiple of only 5. If you observe the colored area of C, we get multiples of 5. So actually we have described here what is set. We now some basic operations of sets. Suppose we have first set ABC union 2, 3. So union will be ABC 2, 3. Similarly 2, 3, 5 union 3, 5, 7 union will be this. So we can write two, there are 2 times 3 and 5, 2 times 5. This is why we can take only single 2 and single 5. So we get the 2, 3, 5, 7. We have to remember this. Repeated numbers for union, repeated numbers will be only single number. So we can write in Venn diagram like this. First set will be 2, 3, 5 and second set will be 3, 5, 7. But union will be what? 2, 3, 5, 7. And intersection will be what? Only 3, 5. So usually in Venn diagram we can shade like this. So we have to think the United States of America includes every person who worked in any US state last year. This is show how RS is. Now the intersection operation, we must know about this. So suppose A, B, C intersection 2, 3, then this equals to what will be? Actually, there is no common element. This is why number of element is 0. This is why empty set. Similarly, for the second operation, 2, 4, 6, 2, 3, 4, 5. What will be? Actually, common element only 4. This 4 set, this set 4 is the actually intersection. So in Venn diagram, we can use this. First set will be 2, 4, 6, and second set is 3, 4, 5. So common will be what? Only 4. So intersection is only 4. So this is the actually shaded region. So this is the required in Venn diagram required set. So you have to think the intersection of university like this. Two sets A and B are called disjoint. That means there will be no common element. Then the set both sets is called disjoint. For example, the set of even integer is disjoint with the set of odd integers. Okay. Now, how many elements are in A union B? Must know about this. So set of difference M difference B can be written as X such that X will be the element of A and X is the not element of B. Suppose for set operation in set difference, suppose 1, 2, 3, 4, 5, 6 difference 2, 3, 5, 7, 9, 11. So what will be the result here? Actually, that means you have to delete the elements of second set from the first set. Okay, so 2, 2 are the same. So 2 will be deleted from the first set. Similarly, 3 also 3 will be also deleted from the first set. So 2 and 3 cancel, and 5 also common elements. So 5 also deleted. So 5 also cancelled. So 1, 4, and 6 are the result only. So we have to remember how to operate the set difference. And A minus B is what's left after B takes a bite out of A. That means from set A, we have to delete the portion of B from the set A. So set A minus B is this red portion only. And all the term you have to crack. And the universal set, you must know the all elements will be there. And so more on set complements. An equivalent definition where U is clear. Complement of A is what? A will be not element X. A will be not exist in the universal set. That means all elements will be cancelled from the universal set. And this identity I have discussed in earlier. So, and this is also De Morgan's law. I have discussed the complement of A union B is the individual complement of their intersection, and complement of A intersection B will be individual complement of their union. I have discussed these two operation. Now, this is the examples of identity. This is the set operation using truth table. Okay, now what is power set? What is power set? A power set can be denoted by power set of A, also written as 2 to the power A. Okay, and power set of A equals to B such that B will be the subset of A. That means contains all subset of A. For example, suppose A equals to X, Y, Z. That means 3 elements only. So power set of A will be, we can find actually 8 subset of A. Pi is the also subset of A, and X is the subset of A, Y also subset of A, Z, X, Y, X, Z, Y, Z, X, Y, Z, all 8 elements here. 1, 2, 3, 4, 5, 6, 7, 8. These 8 elements will be the subset of A. So the set of all this subset is called power set of A. So actually, there are only 3 elements. So 2 to the power 3 number of elements, 2 to the power number of elements will be the number of set in a power set. So 2 cube equals to 8. This is why there are 8 elements. So power set equals to actually set of sets. Here A equals to empty. A equals power set of A will be set. This is not set. This is the empty set, but this is a power set. You have to remember this. So power set of element equals to 1, but empty set element what? 0. So cardinality of power set, number of power set equals to 2 to the power element of A. Imagine each element in A has an on or off switch. Then we can, each possible switch configuration in A corresponds to one subset of A, thus one element in power set of A. So for X, Y, Z, there will be 8 elements. So we get this set X, Y, Z, X, Y, Z, X, Y, Z, different colors. So for 3 elements in A, there are 2 multiply 2 multiply 2 equals to 8 elements. Now Cartesian product, the ordered n tuple A1, A2, A3 dot dot n is an ordered collection of n objects. 2 ordered n tuples will be A1, A2, A3 dot dot n and B1, B2, B3 dot dot Bn are equal if and only if they contain exactly the same elements in the same order. That means Ai equals to Bi, where I lies between 1 and n. 1 less equal to I less equal to n. So this order pair will be same. So the Cartesian product of two sets is defined as this: A cross B equals to A comma B, such that A will be the element of set capital A and B is the element of set of element B. So for example, we can A is the set good and bad and B is the student and professor. So if we take the across B, then the Cartesian product of A and B, we get this one. How many? Good student, good professor. Bad student, bad professor. So how many pair here? 1, 2, 3, 4. So similarly, B Cartesian product A also student, good, student, bad. Okay. Professor, good, professor, bad. Similarly, we can get the Cartesian product of these two sets A and B. So for example, if A is equal to XY and B is equal to ABC, then across B will be XA, XB, XC, YA, YB, and YC. So there will be how many elements? 2 multiply 3, 6 elements. We have to remember that Cartesian product of any set A with empty set will be empty. And similarly, empty Cartesian product of empty set with any set A will be also empty. So for non-empty sets A and B, we get the A is not equal to B if it implies Cartesian product of A and B is not equal to Cartesian product of B and A. So the number of elements of Cartesian product A and B equals to number of elements multiply number of elements B. This is why we got in previous slide 4 elements. Okay, 2 multiply 2, 4 only. So the Cartesian product of 2 or more set is defined as like this. Okay, A1, A2 dot dot cross n equals to the element of A1 will be this, where AI belongs to capital A. For I will be 1 less equal to I less equal to n. So for n times Cartesian product. So union can be written as this: A union B equals to X such that X belongs to A or X belongs to B. This will be the example, A union B. We have also defined in earlier. So intersection will be similar, X belongs to A and also X belongs to B. So this will be the, for example, we get A intersection B will be B is the common element. So cardinality, we can write A union B, element of A union B will be element of A plus element of B minus common element of there. So two sets are called disjoint if their intersection is empty, that is they share no elements. Okay. The difference between two sets A and B contains exactly those elements of A that are not in B. That means A minus A difference B. We have also observed it in our Venn diagram. Okay. So cardinality, number of element of A difference B will be element of A minus element of an intersection. So in our next lecture, we'll discuss about this and prove and solve some real life example. That means application of set theory. Similarly, we have discussed about this complement of a set in our Venn diagram. So complement of set will be U universal set minus or difference A. So for example, if universal set is natural number and B is the 250, 251 dot dot all, then complement of B will be what? 0 to 259, 249. Okay. So thanks to everybody. Bye for today. I hope everybody will enjoy this.